Hi, this is Robert from ITQ. We're here at KubeCon Amsterdam, and I have another guest with me. Want to introduce yourself?
Yeah, hi, I'm Steve Wong. I'm here at KubeCon because yesterday I was hosting an event they called Kubernetes on the Edge Day. So even though Kubernetes is in the title, it was probably a little broader than that. There were some talks that weren't Kubernetes specific, but I was on the program committee for that event and was MC. And the reason I ended up there is I am co-chair of the CNCF IoT Edge Working Group.
Cool. So, so you had a co-located event, and it was half a day, or was it a day?
It was half a day. They call it day, but you know they cut back on the length of KubeCon down to 3 days, and as a result of that, this day got cut to half a day. An interesting thing if you're a conference organizer, because we got well over 100 submissions to talk, many of them just excellent, and it was sad that we had to leave so many great talks out. You know, we have a committee that rates these things on a scale of 1 to 5, and I'd say that there were perfect 5s in there. There were talks that were rated 4.6 that got left behind, unfortunately.
Yeah, that's always happens with these things. Yeah. So so Edge is a growing part of the CNCF ecosystem, or part of, I would say, just an industry trend in general. So what are you seeing around Edge when it comes to the CNCF in particular?
Well, the CNCF has integrated a number of projects that work at the edge. You know, Edge really, it's controversial even how you define it. The looser style would be almost that it's conflated with on-prem, that any physical location that isn't a public cloud is Edge. But there are certainly those who would put a different dividing line, contending that, hey, if I've got a big physical data center, I run it as a cloud, and it is a cloud. Now, the CNCF Edge Working Group, IoT Edge Working Group, we did do a white paper coming up with a new definition of what we call edge native application design. And the reason that we thought that edge native is a quote thing is that if you look at the original definition of cloud native, it was based on the premise of having a farm of servers that you want to maximize efficiency with by loading them up to the largest extent possible, kind of like historically you do with a VMware vSphere installation, where you would maximize your efficiency by crowding as much as you could to take that thing up to 100% utilization. They contended that in public cloud, and this is true, it's more than just a contention, that you have infinite scalability theoretically, that you're renting things on demand. If you have a very dynamic workload, you can expand. Well, Edge Native has to reflect the fact that if you are actually on-prem, you can't rent on 5 minutes notice, excess capacity. What you put in there is largely what you got. The other things that are different is they are not, this homogeneous thing. A lot of these things at Edge, even the lower edge, have life cycles that can be 10, 15 years potentially, whereas in a big data center, 5 years is about the max. Some of that equipment can be replaced in 3. Different story out at the edge. You also have connectivity challenges where you cannot guarantee reliable connectivity up to the public internet. Another big issue, if you get down to some definitions of edge, is no trained staff. Some of these are completely unattended, so there's literally zero staff.
Yeah, think of retail or industrial applications, yeah.
Right, and maybe even if you have people there, they're not necessarily trusted in the sense that you have a strong vetting going on, and if you want to deploy something new or even solve a problem, it's sort of like you've got people who can plug in a power cable or cycle power or plug in a network cable, but beyond that, it can be a challenge.
Yeah, so so of course, ingesting sensor data is a huge use case for the edge, for IoT, and where those two meet. As we build out cloud-native architectures that can handle some of that stuff, we've got other challenges. The amount of data that's going to come into these systems is a big challenge. We used to centralize everything. Of course, the point of having Kubernetes at the edge is maybe we don't need to centralize everything.
Yeah, and exactly, not only do you not need to, but maybe it's a real bad idea. You know, I gave the opening for this talk yesterday, and one of the points I made is that there is a fascinating blog post by a guy who started BigQuery for Google with the provocative title, Big Data is Dead. And the point was that a lot of people invested in these gigantic data lakes, or maybe I'd even go so far as to call them oceans, of let's transport all the data we have up to the public cloud, and we'll figure out what use we can get out of it later. But an analysis of how much value actually got delivered concluded in many cases that the value is in fact negative, that you get exposed to litigation, filings to remove data under privacy laws, and the net value to you of keeping these are effectively, people came to the realization that in the US there's a TV series called Hoarders who never get rid of anything, and their house just gets uninhabitable because of that, and maybe these things are like that. So the solution at Edge might be, and I'm not saying that there's a lot of CNCF projects to do this yet, but my personal prediction is they'll come about because it's such an obvious thing to do, that you need to filter that data down and act on it at the source, and only feed up summaries and selective morsels of realization or events that you got from that data, because the amount of data is growing. When you've got things like 4K video cameras at 60 frames a second, do you really want to forward that up to a public cloud? No. A lot of things are wrong with that, not just the cost, the privacy issues, but it's too slow if you needed to act on it.
So that filtering role is, has always been performed by humans. We're very good at pattern recognition, understanding, what's valuable and what is not. Right? But now we're seeing, of course, the emergence of we've seen it with large language models like GPT. I assume that AI has a big role to play in filtering at the edge and doing processing.
Yeah, it does, and I hope you were joking about humans being good at that. You know, you can hire people manning security camera desks, but let me ask you, at 3 in the morning, watching 20 cameras, what are the odds that's going to be caught quickly? You know, AI has the potential. Some people think, it will put people out of jobs, but I view it as a force multiplier. If you look at the history of the world, the invention of steam engines, then later internal combustion engines, electricity, were a physical force multiplier where it got 12-year-old kids out of coal mines, people destroying their backs, dying before age 40. This AI machine learning has the potential to eliminate really mundane aspects of people's jobs that they hate doing. Now, granted, some people, I think, ultimately will find they enjoyed the move, but it might feel threatening in the short term. And it will allow them to do the things that make them human, be more creative, just get rid of the repetitive stuff that make you hate going into work at 8 in the morning, and throw those over to a machine. So when you come up with this premise that massive amounts of data are coming in from industrial sensors, cameras, whatever, and turn a trained ML inference engine at that, reduce it to summaries. Like, I'll give you an example with cameras. There's a booth by Sony showing some demos of some technology they've got working that I'm told they intend to open source sometime soon. It can watch things like in a scenario of a financial institution, the camera tells you when some people crossed a line. Like, you might have a sign saying, don't go to this area, but it will tell you that somebody entered the area. It throws an event, like an MQT event, and you can use this to drive event-driven logic. You can actually even have it throw away all but the snapshot that this event occurred then, and this was the snapshot. You don't really want 60 frames a second recorded.
Yeah. Okay. Well, that's fantastic. I mean, I'm very excited for these developments, and especially where these technologies meet. This has only been day 1 of KubeCon. We've got a few more days to go. It's going to be exciting, and I wish you a lot of luck, and we'll probably bump into each other again.
Okay, thank you, Robert. I appreciated the invite to talk here on your podcast.
Yeah, no problem. So thanks again, and till next time.